Thank you very much. How was lunch? Was it okay? I didn't get to it because I had to make some tweaks to my presentation because I also attended the first one and I wanted to make sure to not really repeat things. But I think I will grab some food afterwards. And how many of you did attend also the first talk about Blazor? Okay. Oh, so there are also people that didn't attend that. Okay. The idea is that today we're going to talk about Blazor, but it's not that kind of talk where we say, hey, what great Blazor is, let's use Blazor, it's the best, nothing is better. But it's more kind of like a talk, okay, let's look at what really Blazor is and how can we really go about writing applications, like real Blazor applications. And we'll dive deeper into some things like very practical approaches that we could use in order when we develop Blazor applications, because the development model in Blazor is a little bit different. Since Blazor it is a front-end framework basically, so maybe we need to adapt our best practices or the way we were accustomed to write code in .NET in, I would say, normal backend applications. We have to adapt it a little bit to this front-end model. So we'll look into how this is done. Before we get started, just a few words about me. My name is Dan, as you see. I'm a software developer at a company called Amdaris. It's in Romania, in Timișoara. We also have offices in Moldova, and in the UK. And I'm also the founder of a company called Wrinkles, through which I usually deliver trainings both for companies that want to enhance the skills of their developers, but also for people who want to learn software development from scratch, because I was in this situation also around six years ago. And I'm also the co-organizer of a .NET conference in Romania, which is called Apex Vox, and which will take place next week, next Saturday, so exactly in 1 week from now. So I'm also a little bit stressed out with that conference, but I'm really excited to talk about Blazor because it is one of my most favorite topics. And I also have a blog where I usually write fairly often, except for the last 2 months, where I was really very engaged in a lot of projects. But I will keep writing after November 2nd. And I also have a Twitter handle that I use very often, so you can follow me on Twitter and we can get in touch there or through my blog. So let's get started. Blazor. So how many of you did try Blazor out so far? Okay, that's good. The idea is that we will have right now a short Blazor overview. A lot of things were covered during the previous talk, so I will mostly concentrate on things that are really important for this talk right now. And then we'll go into this idea of how do we architect Blazor applications. And we'll go into 3 topics. Of course, there are more topics, but we can't cover really them in 55 minutes. And those topics are folder structure, so how do we organize our features in our Blazor application. We'll talk about components, because component is, let's say, the fundamental idea behind Blazor, and it's similar to Angular. And we'll see how we can communicate between components, because we have different ways to do that, and we have to understand in which circumstances which way is maybe better than the other. And how many of you are also familiar with Angular? Okay, great. And my idea was when I tried to design this type of basic architecture model, I also worked a lot with Angular, and I basically looked there for some best practices. And since Blazor is also basically a front-end framework, I think that there are some best practices from Angular that we could easily port and use also when we develop Blazor applications. So I will have a lot of references to Angular concepts, just to maybe better understand what we really want to achieve in our Blazor app. And also, I have created an application for that, like a real application, and strangely enough, I think I will start by showing this application first. So let's get over here and launch the application. Until it launches, the basic idea of this application is to be a Blazor app, of course, that talks to the GitHub API and takes from there a lot of information and displays in this Blazor application. Of course, we need to log in first and to authorize this application to use our information, like user information, repository information, and so on. So I have this button here through which I can log in. And once I log in, I assure you that there are not really a lot of features right now in this application, but it's the basic skeleton to understand these concepts that I want to talk about. This will be a dashboard at a certain point, but one thing that we have is the user information that we have here, and we can also go on my profile and get this user information. Also the picture is also from GitHub, from the API, so it's not something that we serve locally. And then we have these repositories, and here I could basically get a list of all the repositories that I have. Depending on the authorization permissions that I have for this application in GitHub, we can see maybe also private repositories or only public repositories. And if we click on one repository, we will see more details about this repository, like the branches that we have, or the current branches on this repository, and the issues. And you see here that we have 3 different issues for this application. We display the username who created the issue and who the issue was assigned to. So this is the basic application. As you see here, when I click around different buttons, there is no server reload. So nothing is reloaded here. So this is why this behaves like a single-page application. But there are some other things to it, and we'll get into that just in a few moments, okay? Good, so I'm not sure what happened right now. Sorry. Okay, so let's start by first understanding what exactly Blazor is and what we have seen in this application. Basically, Blazor is a framework to develop applications for the browser. We could easily say that. It really allows us to share also code that we run or that we use basically in our domain or infrastructure, and we can simply reuse it also in our front-end part without the need to use any JavaScript at all. And we can use this, of course, to build rich and interactive UIs, again, without necessarily the need to use JavaScript at all. Of course, as it was also said previously, if you have JavaScript and you might need some functionalities of JavaScript, there is also, of course, interoperability between Blazor and JavaScript. And this could be easily used. Now, the very important thing, and this is really, I want to stress this out. Blazor itself is, I would say, a single programming model. So the way how Blazor is designed to work is exactly the same. However, we have 2 different hosting models. And these hosting models basically only define how the application really runs. But the way you design your application and the way you write code and write your Blazor application is exactly the same. So first of all, we have this Blazor WebAssembly. And this is the case where you basically ship all your DLLs to the browser, including the mono runtime. And that mono runtime translates all your DLLs or your code to WebAssembly. So in this case, all your code is already in the browser when the application is running. Of course, this has some great advantages. It was pointed also during the first talk today about Blazor, but it has also a lot of drawbacks because you have for now a very big download size. Initially, the download takes a little bit longer, so it's not really, really fast. You don't have something like lazy loading for now. So when you first try to access the application, it will download really all the DLL that it will ever need for, I don't know, maybe a functionality that you use only 10% of your time. But this is the model that right now is in preview. So it's not, let's say, under global availability. So now nobody is really encouraged to write productive Blazor applications. It's only for testing, to understand the programming model, to understand the direction towards everything goes. And of course, this would help us when Blazor, or when this hosting model will be globally available. We already know this model, and we can suddenly start and build applications. So when it is here, we will already know how to handle it. On the other side, there is this Blazor server, or server-side Blazor. And here the difference is that instead of shipping all the DLLs to the browser, what happens is that it will open a Signal R connection, so a WebSockets connection. So everything happens on the server, including the rendering, I would say, and is shipped to the browser through this Signal R connection. The cool thing about this is that for the user, everything looks like a normal single-page application, so no page reload when you click around the application. But on the other side, you don't have to download everything to the browser, because everything is handled through that Signal R connection. And the other very cool thing here is that, for instance, if you are in the application and you click on a button, then what happens is that, well, the browser sends through that Signal R connection the information this button was clicked. The cool thing is that the server generates only the HTML diff that it has to be sent, so only what needs to be changed on the HTML page, and it sends it back through this Signal R connection. So this means that every time you click around, this means that not the entire page will be re-rendered, but only the part that needs to change. So this is very, very cool. And this hosting model, so Blazor Server, is already globally available in .NET Core 3.0. So this means that we can already develop Blazor applications using this server-side hosting model. So this is right now fully supported. The idea behind is that once also the client-side or the WebAssembly hosting model will be available, as said, the way you develop your application, the way you design your code, is exactly the same, so nothing changes. The only thing that will change is that you can reconfigure your application not to use the Signal R connection anymore, but instead ship all the DLLs to the browser. So this is why basically I say that today we can already create our Blazor application that we run in production, because we can use this server-side hosting model. Later, if we want to change to the WebAssembly hosting model, that would be fairly easy to do. And that's why the application that I've built here is basically built on this idea of the server-side hosting model, because this is already globally available, and this is something that we already can use. So what we have seen there, even if we noticed when we clicked around there was no page refresh, what happened behind is that this Signal R connection was used to send the HTML differences that needed to be rendered in the browser. So we will concentrate basically on this Blazor server side. However, once again, I want to underline, everything that I say here in this talk fully applies also to the WebAssembly hosting model. The only difference is really how that application really is hosted and how it really works technically, so from an infrastructure perspective, let's say. Good. So now that we know a little bit these differences about different Blazor hosting models and how Blazor is supposed to work, I guess we can go to the folder structure. So this is the first topic that I would consider an architectural topic that we'll discuss. And when it comes to organizing code, basically we have two different approaches or options that we could go. The one is, or the first one, or one of them, is the convention-based model, in which we name our files and folders according to what they are designed to do, so according to conventions. And I assume that most of us were doing a lot of .NET web development, where we are very accustomed to have a folder called controllers, where we, of course, put all our controllers. Then we would have a folder that is called services, and in that folder we will put all our services. The same way we would have a folder maybe view models, and in that folder we will put all our view models. So this is the convention-based way to do things. However, even if we don't really realize, because we are really accustomed to use this model, this also has some problems, because basically we have related functionality that is separated into different folders. So when you receive, for instance, a bug request, or somebody notices a bug and you need to fix it, basically you need to go first to the controllers to see if there is a problem there, then maybe to the specific service that is used and check if the problem is there, or maybe the problem is in some logic file, whatever. So you don't know exactly where to look in the code. You always have to go, or mostly you would have to go from the controllers and then check all connected classes and dependencies and so on. On the other side, we have an organization model that is called the feature-based, and this is the typical folder organization for single-page frameworks like Angular and React. And in fact, in the Angular style guide, this is also the recommended way to design the folder structure in an Angular application. And the idea behind this, this folder structure is that folders are organized by features. So in that case, we would have a folder like, I don't know, users. And maybe in that folder, we would have then all related files or subfolders to this user's functionality. So we would have maybe the view models, we would have controllers, we would have whatever else is needed for this specific feature to work. The good thing about this model is that, of course, when you receive a bug or a maintenance request and it says that, hey, you need to do something in the, I don't know, users feature, then this would mean that you know exactly where you need to look. And you are sure that the changes that you have to do will be in that users folder. Of course, there might be in different files, but at least you already know exactly where to look. And in an application where you might have hundreds or maybe also thousands of different features, I think that this might be very, very useful. And then, of course, there is the question, what is then the best way to proceed? As I mostly say, there is no really a best way. It mostly depends on what we are doing. But my idea, at least when it comes to Blazor, or generally to single-page frameworks, is that maybe when we design backends, and only backends, the convention-based model works just fine. But when we design applications to be used as a single-page application, then maybe we should use the second option, so the feature-based option. Why do I think that this is where maybe a good way to proceed? It's because when we have normal web applications, like you don't have really a ton of features. And when I see, of course, we can have really big applications on the web. But on the other side, if we think about a front-end application, just in one page that you would see, it could be that you have there, I don't know, maybe 100 different features. So usually, client-side applications or single-page applications are more feature-rich than the normal web-based applications. Because in the end, on the web application, you just have, I would say, the business logic. But on the front end, you have all of the entire rendering logic. And this will take really a lot of different features. So my idea is that we should use, for Blazor, probably this feature-based approach. But however, no matter which approach we use, one principle is always very, very important from my point of view when it comes to folder structure, and this is that we should keep this, the flattest folder structure possible. This is really, really important, because if you have deep hierarchies of folders, then it will be a nightmare both for you and for other developers that might work on that application at a later point. Okay, then we have seen first that, okay, we have this idea that we will organize our code by features. But on the other side, if we think about Angular, we have also these two different folders which are called core and shared. And I think that this is also a very good model to bring into Blazor. Why? First of all, let's look at the core folder. So in the core folder, in Angular, you usually put singleton services or directives or whatever, but usually services that you reuse throughout your application, so in most of your components. And here we could easily also do this in Blazor, although in this case, especially when we have server-side Blazor, these services won't be singleton services, because if you have a singleton service, it will be the same for each session. So then once a user is logged in, everybody else that wants to use the application will be logged in as that user. So that's not OK. But generally, we can place here services and generally classes that we reuse in some way throughout the entire Blazor application. For instance, we could have some logging services, some error handling service, a data service if we need, and we can have an app state service, which for Blazor could be very, very important, and we will look into that a little bit later. And then in the shared folder, you could easily put different components that are usable or that you want to reuse throughout your application, like buttons, like, I don't know, maybe common data grids or arrows or notifications, whatever simple components that you might want to reuse throughout your application. And these components should usually be non-routable, so they wouldn't be available through a certain route. They are simply a button that you click or a drop-down that you click to see some information. And we could easily place everything in this shared folder. So let's take a look and see how the folder structure of the application looks like that I just presented. Let me close it for now. And let's go to Visual Studio. So this is the application. And you see that we have a domain where we have our domain classes. But we concentrate on this GitHub dashboard app, which this is the Blazor application. So first of all, we have here this folder called features. And you see that here we have different folders that are responsible for a certain feature or that represent a certain feature. Like we have this home, but in home we don't have anything yet. But we have a layout. In the layout, I have put the layout that I want to use. Also, we have some code behind, but we will look into this just in the next topic. Then for login, I have this login folder, and all services and classes and components that I need to log in a user are placed here in this login folder. And then I have this profile, where all things that are related to my profile are placed here. For the profile, there are not a lot of things, but if I want to enhance this feature, everything related to this feature, I will put here in this folder. And then the most feature-rich right now is this repositories, where we see that we have also subfolder, and we look better into this subfolder with the next topic. And we see that we have my repos, and we have repo details, and here we have different components regarding repositories. But notice that everything that is placed under this repositories folder strictly relates to this repositories feature, which was basically the list of repositories that we saw on the application when we clicked that specific button. So this is how the folder structure looks like. Let's go one step further now and go into a second very, very important topic, and this is designing Blazor components. Components are really very important because they are the main focus of Blazor. Like we have components in Angular, in a similar way, we have components in Blazor. And the role of components in Blazor, similarly to what we have in Angular again, is to basically group together markup and functionality. So we have on the one side things that are rendered, so things that will be our UI, but we want to have some, I would say, code behind, some functionality, some logic that we will use. And these are basically grouped together into one component. One difference to Angular is that for now, at least, we don't have also the CSS tied to it. So we have only markup, so HTML or Razor syntax, and logic, so normal CS files, but no CSS files so far. And when we try to create this type of components, we also have different options to do that. And one type of component is that what is called an inline component. And this component is not really very, very fancy and complicated. The whole idea is that here in this component, you have only one single file that you could name as hello-world.razor, like it is in this example. And in this file, you have, on one hand, some markup, like we have this title here. But then, in the same file, you also have some code. Which means some real C# logic, or code written in C#, plain C#. And this code directive in Blazor really indicates that here in this block you will put only C#, so no markup at all. And here you can create classes, whatever you want. You can do basically anything that you can do in in a Blazor application. Now, if you worked with Blazor, I don't know, for a longer time, you might see that at the beginning, the directive that was used was function, here or here. However, this was replaced starting with the preview of preview 6 of .NET Core 3.0, so around June or July, I guess, with the code directive. However, for now, you can use both of them. So you could use either code or function. But right now, all the documentation and almost everybody is using this new directive, which is called code. Here, please bear in mind or keep in mind that this idea in the inline component is that we have in the same file markup and C# logic. Then we have the second type, which is when we have markup and logic splitted into two different files. So we would have something like hello world.razor, and in this file we will have only the markup, so Razor syntax, and we'll have separately something like hello world.cs. And in this file we will put all the logic behind. How this would work is that on the Razor file, so on the markup file, you could use the inherit directive that will basically bind our markup part with the logic part. So you can then use the functions that, or I guess we should call them methods to be 100% accurate. You can use all the methods that you have in your logic. You can use them also in the markup. And there is one convention here, and this might change really in rather a short time, that we should name the file where we place the markup and the file where we place the logic with the same name, like, for instance, hello world, but then the markup file would be hello world.razor, and the logic file would be hello world.razor.cs. There is one problem here, and we will show this also in code. Or why we will have to do this is because in Blazor there was, or partially there still isn't, any support for partial classes. So you cannot really bind directly two files or two class names that are really the same. So we needed to use this convention. But however, in .NET Core 3.1 preview 1, I guess, there is already support for partial classes, and then this convention is not needed anymore. In this case, you can name your markup and your C# file exactly the same, only the extension will be different. So we would have hello world.razor and hello world.cs. Good. And then there is the third type of component, and this is a little bit more tricky, and nobody will use it, and it's also not recommended to use it. To use basically class-only components. And why this is important? This is important, or it is important to know about them, because this allows us to better understand how the Blazor rendering engine works. What happens when you write a component, no matter if it's an inline component or a component with code behind? When you compile the application, what Blazor will do, it will create a class that is similar to this one. And here we see that we have this build renderer tree, and we have this builder, and the entire view basically is built using this add component, add title, add value, and so on. So in the end, everything is compiled to something like that. And this is also why, if you watched .NET Conf in September, the idea that we could easily, or we could try to replace the rendering engine in Blazor, so instead of rendering HTML components, to render maybe XAML, or something like that. And this would open, basically, the door to have Blazor as a programming model, but write applications that would run on desktop, on smartwatches, on smartphones, and so on. So this idea that we have this renderer that we could simply replace with a renderer that instead of rendering HTML, it would render XAML, is very, very powerful. However, in our code, never use the class components, because you can imagine for a component that has a lot of HTML, you would have to write a lot of things then, and surely you would get a lot of things wrong there. Inline components are great for demo purposes, like when you have a demo application like the standard Blazor template, because you can easily see on one file, hey, this is my markup, this is my logic file, my method, and here is how they work together. But when you start to build real application, you will see that this will get very messy very fast, because you would normally have a lot of markup. Imagine all the HTML that you would have to write, for instance, I don't know, to render a table, or a data table, or whatever. So to have on one file both the markup and the logic is not really the optimal way to do it. Also, from my perspective, it is good from an architectural perspective to really segregate these different responsibilities. Because here we have two different responsibilities. One file, or let's say the markup part, is responsible for rendering the UI part, while the CS file is responsible for all the logic behind. So it's like the single responsibility principle applied to this architectural guide. And of course, class components, well, they are really cumbersome to use. That's why the best way to proceed with this is using this code behind components. And the code behind components, we'll look briefly into some of them. Let's look into one where we have some more logic. And here in the login feature, we have this GitHub component. And here, we see that from the markup perspective, we actually don't have anything here. And the reason is how the entire authorization flow works in this application. By the way, I've built this application before authorization was available in Blazor. So right now, there are really easier way to handle authorization and authentication in Blazor. But when I built this application in August, those did not exist. So the flow right now is when I want to log in, I send a request to GitHub. Hey, I want to log in with this username. Then GitHub sends me back a code that I have to use once again to get a JOT token afterwards. So what I do with this GitHub component is basically I don't need any markup. I don't need anything to show here. I just need a point where GitHub would send me the code from where I could take the code and really do the login. So here in this case, the most things that we do are basically in the code behind part. And here we see that we have different services that we inject here. And what we do here is, OK, when this is rendered, so when GitHub sends me the code back, what I want to do is I want to extract the code. I want to create a post model, so to create the login itself, and then to log in that specific user. And when everything is done, I just want to navigate back to the home page. And this is what happened when I clicked on that button to log in. So this was the entire flow that happened here. But what you can see here is we have this split up between this component and this code behind. This is, of course, also true for the login. And this is the login page, so where we had that GitHub button on which we clicked. And then we have here the code behind. Here the logic is not really, really complicated, but here I could take where I have some properties that define where I want to make the request to log in a user. And I also have the post model. So I have the model that I use for login also here because it belongs to login, so in this feature. OK. And what we see is this inherits. So this is the way we basically bind this CS file, this github.razor, sorry, to GitHub razor.cs. And although the files are named the same but with different extensions, I couldn't use the same class name. So this is why this is called GitHub model. So I added the model behind it. Right now, with partial classes in .NET Core 3.1 Preview 1, this should be already possible to use a partial class, so I could use GitHub mod. I could use only GitHub, so not GitHub model. And so those files would work as partial classes then. OK, so this is how components and the code behind looks like. So let's get into the next topic that is really, really important. We still have a little bit of time, so I think we're on track. Of course, we have all these type of different components, but as the case is also in Angular, React, and other front-end frameworks, we also need to communicate state between different components. So how do we do that in Blazor? Well, we have different options that we could use. We have three. First of all, we have what we call parameters in Blazor. And these are nothing else than, or they look like normal properties that are decorated with this parameter attribute. So nothing special about them. But what this attribute actually does, it instructs Blazor then that we should think about this property as a property through which data can be communicated from a parent component to a child component. So we can think about this parameter as an input attribute in Angular. So it works more or less exactly the same way. And we'll see also some examples for this. We just simply specify the parameter name and pass in the value that we want. And we do this in the parent, of course. But surely we would also have scenarios where we would also need to communicate from a child to a parent. So in that case, what we could use is event callbacks. And event callbacks are also properties, but of type event callback of T. And in that T, of course, it could be a placeholder for a mouse event, or it could be a placeholder for anything that we really want to pass through that event callback. This is nothing else than a delegate. And how this would work is basically that when something happens on the child, the parent components provide a method that wants to be executed when that specific thing happens. And then, of course, when the thing happens, this event callback is triggered, and on the parent, or the parent receives receives that T, which could be a mouse event or string or whatever we define there, and then can perform some actions based on the information that it received. And this is a very powerful way to communicate, as said, between parent and the child components. But here I also recall a very, very nice pattern from Angular, from the Angular style guide that we could use, which is generally called the container presentation pattern. And this is a really, really useful pattern when we have parent components and child components. What is the main idea? The main idea here is that we have, on the one hand, the parent component, which in this case we call the container. Why do we call it the container? Because this component is the one that is responsible for handling state. And all the childs, which are in this case presentation components, these components do not handle state at all. So basically what we do is that from the parent, here we handle state, so we get the data that we need. Then through these parameters, we can pass the data to the child component, and the child component is responsible for rendering that data. The other way around, if something happens in the child component, there would be an event callback that would notify basically the parent component, hey, this has happened. Then the parent component, if it thinks that it needs to change some state, to add something or get new data, update data, whatever, it would perform that state update, and then once again through the input parameter, it will send the new information to the child component. So the very cool thing here is in this pattern, of course, that we have this only one place in this entire hierarchy where we handle state. And the presentation components, they are I would say fairly dumb in a certain way. They only need to render something on the UI and notify the parent component, the container, when an action has happened that would maybe trigger an update or a change of the state. And let's also look into the application to see how this is implemented. Okay. So we can see this in the repositories feature the best. And here in this repositories feature, I have first this repo details. Let's first look at the code here. So repo details, we see that it has the app state service injected, and it has the GitHub API client. This GitHub API client is nothing else than an HTTP client factory that creates a new client, exposing the methods that we want to interact for GitHub, like login, get repositories, whatever. So this is my GitHub API client. And what I do here is, of course, when this component is initialized, you see that I interact with that API client. So I get a list of repositories, I get the branches that I need, I get the issues that I need. And when everything is done, well, I say that the data was loaded, and this will trigger some changes on the UI to really display the data. And of course, there are some actions here. Then when we click on different buttons, it should deactivate the issues and so on. But the main idea here, or the focal point here, is that in this component, I really handle state. Because, OK, it's true, I don't update anything right now. But this is the component that talks to my data set in a way. In our case, it is the GitHub API. And then I have these different child components, like branches. And let's look also in the code behind. You see, I have only few properties. I wouldn't need the API client at all, I guess. But I would need a list of branches and maybe the app state to know the logged-in user. But the GitHub API client, I wouldn't need, so it skipped me. So I should have taken it out. But you see, we don't have any kind of logic here. So this component is only responsible to perform the rendering. In this case, the rendering is simply going through that list of branches and displaying them in a table or in cards. Here we use cards. Then we have these report issues. And once again, in the report issues, we have this parameter through which the parent communicates the list of issues to that component. And then the component is only responsible to render it. So no logic in this component. This is a presentation component. So how is this all wired up? And for this, we need to go in the parent component and in this view part. And here we see that at a certain point, what we do is simply say, here I want to use that repo branches component. Then I use the branches parameter, and I pass in the list of branches. In the other div, I say that I want to use the repo issues component, and I use the issues parameter, and put in there the issues that I got from the GitHub client. So this means that this is the way I really pass data from the parent to the child. So when this is passed, basically, so when this happens, I pass this data to branches. So if we go to report branches, let's go in the logic part. It would mean that this property now would have the list of branches that the parent has sent me. And then in the rendering part, I would be able to do a for each and write or display each branch on the browser. So this is how this idea of a container presentation works or would work in Blazor. So let's get one step further, and I think we're fairly good on time. OK, but of course there are a lot of, let's say, scenarios where communicating between components is not something simple like communicating from child to parents. Like, for instance, maybe if I would add a new repository directly from my application, if I have somewhere in the navigation bar, let's say, displayed the number of repositories, I would like that also this notification component will update and reflect the current number based on what I have added. Or if I delete, I would like that number to decrease. And of course, these components would be in total different places. So there wouldn't be any real hierarchy or a link between those two components. But we would still have to communicate between them. And the easy way to do is to use something like a state service, in which you basically create some delegates, and different components could basically subscribe. And when something happens, then a notification, or, well, all subscriber will receive that information. Something has happened, a new repository was added, and the notification component could react at this change, and to increase the number that is displayed in that icon, maybe where I see the total number of repositories that I have there. And this service could be a really simple service, similar to what we see here. But of course, we could implement even more complicated patterns. And in fact, what my plan is, I would like to build something like NGRX for Blazor. So a very complex state management mechanism. Of course, this is something that I surely wouldn't be able to do alone, but I'll publish when I start to work on this, and if you want to collaborate, I'm more than happy. But I think that this is a good idea to have a similar service. So that would be from the content perspective. So right now, I'm open for questions. Oh, thank you. I would have expected this in the end. So, any questions? Oh, okay.
Thank you, Dan.
Yeah. So, if I look sad, I'm not sad, but this light in my eyes, it's a little bit disturbing.
Yeah, thank you for introducing us to Blazor. And I would like to ask, is it possible and is it really easy to debug? Like, if you have WebAssembly, let's say,
yeah.
How do you debug it?
Okay, this application doesn't use WebAssembly, but debugging is yet not fully supported when running Blazor client-side. So this is something that Microsoft is currently working on. Probably it would be shipped, I think, in this autumn, in the next preview version. But right now, there is no debugging when you run it via WebAssembly. If you run the server-side Blazor, you have full debugging support.
Okay, thank you.
Welcome. So,
thanks for your presentation. It was really interesting. My question is regarding the CSS. You have told that it's currently not supported. So, do you know if there is some work done in this direction? And in addition to CSS, are there any plans to support CSS preprocessor like less, SAS, etc.?
Okay. No, but the idea here is that what I have said is that the CSS is not fully incorporated in the component. So it's not like you have in Angular, when you create a component, you have a TS file, you have a CSS or SAS or less file, and you have an HTML file. So I was thinking about that. But on the other hand, working with CSS, it's like you normally work in a web application in .NET. So you can still create your own CSS there. You can use preprocessors. So there is really no restriction on that. Only that we don't have separate files with each component, where we specify only the CSS. So we would work with the CSS the way we are, let's say, we are working right now in normal web application that we create. Does this answer your question, or not? Okay?
So you mean that the only way to work currently with CSS is inline styles, or
no?
What do you mean?
What I mean is that you can create your CSS files.
Yes, but how can you attach them to make them work together? So, or you can simply create them aside, and they will work.
No, you would have a folder with CSS files, and there you can either create one CSS in which you put all your CSS, or you can create per feature or whatever, how you want to organize that CSS files. All those CSS files can then be loaded through the layout.
Oh, I see. So
they will work.
Not only from folder structure like support, right?
Yeah.
Okay, thank you.
Yeah. Welcome.
Any questions?
Thank you for your talk. And my question is, you said about WebAssembly way of rendering and server-side rendering. And I wonder if we have a server-side rendering and have big amount of users, will it increase load on server? And can we use this way of rendering on many amount of users?
Yes, of course we can do that, but this gets also into the discussion that goes, I would say, also a little bit beyond Blazor itself, because whenever we have a website, basically, if we have a lot amount of users that are trying to access that website, we have to think about how do we scale this website. So, of course, if we have only one instance of the application running, it will support really a lot of connections. There were load tests made with some millions of requests, and everything went well, because also Microsoft fully says that enterprises can really use it. But of course, if your application is that popular, like Facebook style, then you have to think about ways how you can distribute it.
But then we have a problem. From the one way we have WebAssembly that we have to wait to load, and the other hand we have we cannot. We have many requests for rendering, so it's like maybe better to use Blazor for some closed systems, like for companies that not when we can load WebAssembly, not for rendering on server side.
Well, right now. The WebAssembly version performs far worse than the server version. Of course, I think this is the type of thing that is very opinionated in my mind. I personally would, if Microsoft says that it can handle enterprise scale applications, that I will totally have faith in it. Because basically what it happens that each request or each browser that wants to access your application will get a separate connection, so a separate WebSocket connection. So the whole idea is, okay, how can you distribute those WebSockets connection and the application itself just to respond fast enough? But I still stay to my opinion that in these cases, or these concerns are not only for when we have Blazor. So these are concerns that are generally for each application there. The only difference is that each time you make a request, it goes to this WebSocket. Otherwise, it makes a normal server request. But we can discuss this afterwards. I see you do not agree, and that's good, actually.
Okay, any questions? You can continue discussion on Speakers Lounge. Thank you.
Thank you very much.